I'm Philipp. Let's do some logging. Who likes logging? It's not a trick question, don't worry. There will be trick questions later on, so we'll talk about that later on. So logging is often something like we want to log all the things because we want to see what is going on. And then it might happen over time that we have something like this. We say, this is fine. This is probably many of us, but you don't have to raise your hand. And at some later point in time, you have something like this. Where you have this small little log file and you're looking for something in that and you try to grab and nothing is working anymore. And that is one problem. You have a humongous log file and you don't find anything. I think we have 2 more seats over here if you want to sit. Don't be shy or stand if you like to. The other thing that you have as a problem is maybe that you have too many containers, or you're using Docker, or you have many servers, and it's very hard to find what is even going on where. And at some point, the good old SSH and tail approach is not really working anymore, so you want to do something else. And then we figure out that nothing is fine anymore, everything is on fire, and everything is terrible. And we don't want to really get into that terrible state, so that's what we kind of want to avoid. So I work for Elastic, the company behind the Elastic Elk Stack. Maybe you've heard that or used that already. And we do a lot about logging. And this is not just about our stack, this is about general approaches of how to work with logs. I'll use our stack as an example, but let me show what you can do about logs. So maybe somebody has seen that one already. So Elasticsearch is the thingy that stores the data. Logstash is the thing that gets and parses the data. What do I mean when I say parse? Yes, so for example, you have a log line, and then you have in there a timestamp and a log level, and you want to extract that to work with that. And that's, for example, what Logstash is doing. Then I have Kibana to visualize all of that and show it, search it. We'll see that as well. The problem is we added another component at some point called beats, which is like a lightweight agent or shipper, which is basically tailing a log file and forwarding it away from the host and doing that as cheaply as possible. There's no bee in elk. So what do? You make up another animal, this one here. You see it's a bee, it's an elk. We call this the belk or the elk bee. Because, well, you see, it works together. The other thing is, we're always very concerned about scaling. And this is, from a marketing perspective, not very scalable because, well, what happens if we add another component and another letter? It will get very hard to make up another animal. So now we just try to call it the Elastic Stack. But if you say elk or belk or elk bee, we will understand, and I didn't get them out, but I have belk or elk bee stickers here as well if you want them. So I will hand them out after the talk. So what you have stack-wise in the end is something like this. So you have beats, which is like the lightweight agent or shipper that can forward data, for example, to Logstash, which will extract the pieces of information that you want to have. That will then store everything in Elasticsearch. This is where you store something. There's no other database behind that, for example. This is what is writing data to disk. And then Kibana can do the visualization. Or, in other scenarios, we'll see those as well, beats can forward to Elasticsearch directly, and then we just store everything in Kibana. So this is pretty much very quickly the stack. If anything is unclear, just shout. But I'll show you some practical examples. So we'll use Hello World applications. This is very simple. Like, your applications will be much more complicated. But for getting started and understanding what is the general idea, this will be good enough for today. So I will use Java. Who is using Java? Okay, not that many, but if you, the samples that I show will apply to pretty much any other languages. Just some details are, or the syntax is Java, but the approaches are very similar to many other things. So for example, in the Java ecosystem, it's a bit broken up, the things you can do. For example, we have SLF4j, that is basically the logging facade, or that is the thing you're talking to. And then you have a logging backend. I'm using logback. This is the thing that writes out the log file, for example. And then there is MDC, which is Map Diagnostic Context. This is basically structured information that you can add to your events. Why structured information is relevant, I will show you over time. And then there are multiple alternatives to the libraries you could use, but those are implementation details that are not so relevant. If you want to do this with any other programming language, you can. It's just a different logging backend, basically. But the idea is generally totally the same, and the concepts will totally translate to these others. So you just have a logging backend that is writing out the log file or forwarding your log somewhere, and then we'll see what that somewhere or how that approach is actually working. So let's see what we can do. Two other things before we get started. First off, this is what we don't want to do, right? We probably want to have proper log levels, and we don't just want to print any errors, so we don't want to have that. And the other thing that we don't want to have is too much coupling. So what we don't want to have is like our logging backend is down, and then we don't see any logs. Or we try to upgrade our logging backend, and then we have to redeploy or change our entire application. That is also something we don't want to have. So we don't want to have too much of that coupling. We want to decouple the logging backend as much as possible from our application, just so that it's kind of simple to get started. So let's do something. And let me start my demo, and hopefully my demo works, because we are starting everything from scratch here. And this will take a while. But while we do this, we can take a look. So my Hello World application is like 40 lines of code, or not even that much. Java doesn't really matter much. Basically what we do here is I have a loop going from 1 to 20, and then I loop, or I have structured information. Basically, I generate a random string, which is 0 to 99, which is the session. This is pretty much like a user key. I'm simulating a user key. And I add this as structured information to every log event. This would be in a regular system, for example, if your users log in, that would be what, for example, would be the username. So if a user complains afterwards, like your site is broken, you could just look at the logs for that specific user. We'll simulate that with that session here because we don't have logins or anything. But this is something structured where if somebody complains, you can just look at what did that user do, what are their logs. And then I'm adding the loop iteration here, so I know this is the run 0, 2, 3, 4, whatever. But that's also just structured. Then for every element of that loop, I have a log event where I just log out iteration and session. And then I have this pattern here at the bottom. What is the pattern that I have here? So I can divide something by 15. I throw a runtime exception, divide by 5, a warn, divide by 3, an info, and otherwise I debug. So there is one of these will always come out. What is that pattern? Yes, FizzBuzz. Those of you who have been doing job interviews recently probably looked at FizzBuzz because that's a very common question or example. We are logging FizzBuzz. Does this make any sense? No, but for Hello World it's fine. We just need some log events. So we're logging FizzBuzz. What is kind of more interesting is, so this one will log one of these on different log levels plus one trace statement. And we have this loop iteration here. How many log events will we get? Yeah, generally 40 would be good because this is 1 to 20 inclusive. So this is 20 iterations here. And then we have one trace statement for each. And then we have one of these others here. And that is a general idea. And we basically set that up with Docker Compose. So I have those who do Docker Compose. This is just an easy way to make this start and work. So basically, I set up one Elasticsearch instance, I have one Kibana instance, then I have my Java application somewhere at the bottom, and then my file beat will forward the log file to my application. And what you have in the log is something like this here, where you see, okay, we have a timestamp, we have a log level, we have the class where this is coming from, the method, then I say session and loop. This was this structured information that I was adding, and then I have that log event here. By the way, one other thing that I didn't really mention, what is this? Yeah, it's Unicode, but anybody guesses what this is? Yes, this is an emoji, because you know you always need emojis everywhere, and this will demonstrate that the entire stack supports emojis. So you can log the user happiness in emojis. For example, if your users are not that happy, if we go further down here, you can see here, this is the current user experience. And you can have all kinds of smiley faces or whatever. So this is important features. So while I have been talking, we have something called in here called an index pattern. And the index pattern is basically anything that you want to show in Kibana needs an index pattern. And we can create a new index pattern here. For example, the example that I'm interested in here is the structured example. So I can just say I want to have structure. I'll add that one. It will say like, hey, I have a timestamp field. I'll get into the timestamp field in a moment. And then we'll see how we can add this. So we have picked this one here. We'll switch to the right index, the structure index here. And then we'll see the number of events. How many were we expecting? 40. How many do we have here? 40 as well. So this is good. And this here shows us that we get the 40 events that we were expecting. And this is, nobody paid attention. We said we want to do the parse example, and I started with the structure example. We'll do the parse example first, because that's where I wanted to go. Give me a second. We'll need to add that index pattern for parse. Oops. This is the one I want. We have a timestamp field here as well. And we'll switch over to the parse one. How many events do we have? 42 is always the right number, right? But not today. Something went wrong, and we will need to figure out what. Let me just show you one event here. So for example, here you can see we have the log message, and we have a session, and we have a loop, and we have a log level. Now I could, for example, just show that log level by toggling this column here. And then I can just see like, okay, we have 42 events, and I can see what all these events are. Can anybody already guess why we have 2 that don't have a log level here? Because 2 went kind of wrong. We were expecting 40 events. We have 42. Any guesses? So what we have, and what is the problem here is, let's see this one. Those who have been using Java, what is this? Yes, this is part of a stack trace. Is one line of a stack trace very helpful? Normally not, right? Because one line of a stack trace is just like piece of broken up information. So what you probably don't want to do is we don't want to break up our stack traces. So what we have, like just to show you from the Java application here, is this here is the runtime exception that we've thrown, and then basically we have taken this line, and then we extracted this single line and this single line. So we have kind of broken up the stack trace, and this is not very helpful. Will it be easier to combine the stack trace after the fact again together, or will it be easier not to break it up in the first place? Not breaking up in the first place will be much easier. It's pretty much like you have the steak, and once you have hashed it to make a burger out of it, getting the steak back will be very hard. And it's pretty much the same with stack traces. Once you've broken up the stack traces, it will be very hard to recombine them again. So how do we do that again? How did I say that we collect the log events? So there's this little forwarder or agent FileBeat that is collecting the log file. And what I need to do basically is I need to tell FileBeat how to correctly collect that log file. So I don't want to make this a separate event. And when you look at it, you can see every other statement basically starts with a square bracket and then a timestamp and whatever. So what we could basically say is like anything that doesn't start with a square bracket is probably a stack trace. And it shouldn't be broken up, but it should be combined with the previous line. And we basically just need to enable that. And this is a bit like a cooking show where I have prepared everything already. So this is the rule that you want to have here. So basically what we're doing is we're looking at the log, all the log files that we have in here. Then I need to tell it, hey, don't break up unless you have a square bracket. So you can see the line starts, you escape the square bracket, it starts with a square bracket. If it doesn't start with a square bracket, it's a continuation of the previous line, and we want to keep it together. And then we will forward that and do that. And we can just restart it. We'll just run our Java application again. How many log events will we have in total? Hopefully 82, 42 now, 40 new ones. While I'm talking, maybe this is already happening. So let's see, when I refresh that, might take 1 or 2 more seconds until it shows up. And now 81, come on, one more. 82, now. Okay, so now we have all the 82, and look, you can see these here, they all have the right information. One other thing, or basically the next step, we have forwarded the log line. So we have been forwarding our log line, this one here, and this is just a log line. But when I look at my actual event, then I have it nicely extracted. For example, you can see we have a log.level in a warn, and we have a log method in main. And all of this we have extracted from this one here. How do I get to that? How do I parse out these pieces in our stack? Yes, so Croc is basically a so-called named regular expression. You can just run the regular expression to parse out the relevant pieces of this one here, and then to see what is going on. So what is kind of relevant here, and let's quickly go back to the slides because we've been kind of like skipping over some details here. So basically what we do here in general, we have a log file. The file beat is tailing the log file and forwards it to Logstash. Logstash is running that Croc pattern or regular expression to parse the individual pieces out. We store those in Elasticsearch, and then we can visualize those. This is just how the Docker setup works here. This is not so relevant. Basically, we just tail that log file and collect everything out of that log file. And then we need to figure out how to correctly parse that. And the parsing is, the relevant thing is this link here, just to show you. This is basically what is Croc doing. So Croc is, like I said, a named regular expression. So rather than writing this regular expression here, you just use this pattern. And you can reference this prepared thing here. And for example, for a timestamp, we have a lot of different timestamps that we support. I know, for example, that in my example, this is the right pattern to parse my timestamp. So I can just use this one, and then it will parse that correctly. So we can copy this one here, and then we can try to parse. Who likes writing regular expressions? Yeah, this was kind of a trick question, because those who raised their hand, they need to help me out now writing the regular expression. Also, I always say, like, those who like writing regular expressions, it's a bit like Stockholm Syndrome. You get so used to doing something that you accept that this is the right way. And for some people, maybe it's even like job security, because nobody can probably read your regular expressions anymore afterwards. So here we go. Let's see how we can do regular expressions. Or the easiest way to work with regular expressions is we have a so-called Croc Debugger here. And the Croc Debugger, what you can do is we need one log line here. I'll keep it simple and take this one trace statement. What you want to do is you paste in one log line, and then you define the Croc pattern, you can simulate, and then you just try to extract the right pieces out of that. So those who said they like writing regular expressions, what are we typing now? How do we parse this? So the line starts, then we have a square bracket, but we need to escape the square bracket. So we will need to escape the square bracket. Then we have a Croc pattern, because now we have that ISO timestamp. And to reference the Croc pattern, what you basically do is you do percentage, curly brace, the name of, not the regular expression, but the timestamp. Then you do a colon and say, like, into which field you want to put this. So for example, this I can call timestamp. And then I can simulate this, and you can see now we have extracted the timestamp here. Okay, what do we do next? Yeah, we need to close this one here again. Then we have a space. You could either just type a space, but there's another nice trick that I can show you, is that you just use this pattern here, space. This will basically eat any white space, so one or more spaces or one or more tabs. And since I didn't say put this into a field called space, this will be just removed because I don't put it into a field. And then I have, this here looks like a log level, so we apply the next rule, and I think that one is called log level. We put it into a field, but let's say log.level, if I could type it correctly. And if you simulate that, you see this one is working. So we have the timestamp extracted, and then we have log.level, and we have the trace in there. And then you could write the rest of the line, but this is probably pretty boring to watch me type in all the regular expressions. So this will just work, and it does the parsing. And this is also how we get here to our logged events. So you can see I have my one message here, and we have extracted all the relevant information. So here we have the log package, the loop, the method, the log level, etc. All of this is nicely parsed out. And what you can then do is, for example, here you can just say a filter, and I would, for example, say I'm interested in log level, and I want to say is, and then you can just say what level you want to have. And I could just say this is an error. And then you have exactly the one error that you were running into. And we could open that one up and see what is happening here. And you can see emojis work everywhere because this is important. So this is mostly what is relevant here. We'll skip some not so relevant parts. The good thing about this approach is you don't need to change your log files because it's the classical log file that you already have. The downside is you need to write that regular expression unless you like that. And you need to be careful with multi-line statements because if you break those up, they won't work that well. And you have some coupling because if your application changes how it logs the format, you'd always need to change the pattern how you parse it apart. And they too need to match. So you have a bit of coupling between the two here. So what could be alternatives? What could you do instead than parsing? Yeah, that's point 3. We have something, I throw in something in between, but it's a very good point. That's also kind of what we would recommend in the long run. What else could you do? You could send directly, which looks something like this. You have your log appender, because what we were doing in the previous example was kind of like not so helpful because our application knew what every single one of these fields were. And then we basically wrote them out to one log line, and then we parsed them back. And it's kind of unnecessary to know what it is, write it out, and then parse it back. So what we want to do instead is the application knows what each field is. You can just forward that to logstash directly and then store it. And all you need to do in your log appender, so those who like XML feel right at home here. So we basically have a logstash access TCP socket appender, which is kind of a long name, but it just sends what is in your application directly to a TCP socket rather than logging it out to a file. Here I tell it, this is where logstash is living. So the Docker DNS name for that one is logstash, and the port is 4560. Just send it here, and we're done. And we can just look at those events. So this is the send example. Let me just quickly add the send index here. So we have an index pattern. We have, we create a new one. We say send. This is the one we want. This will pick up this one index. This has a timestamp again. If I look at that log or those logs, how many events do you expect? 80? Let's see. So first we need to remove that filter because otherwise you will just see one. And then I go to the send index. And right now we see 40. And we also, let's say, last 1 hour so that nothing has timed out. Is this what you were expecting? So just for comparison, like if I have the parse index, we have 82. Because I was running the application here. And I was running the application here again. And if I go to send, I only have this one. Why am I missing these logs here? Any ideas? Yeah, so first off, the fields and everything work. So you can see here we have the session, the port, the log level, whatever. This is just working. We don't have the full message because there was no full message adjust. This is just the actual output, but not that line we need to parse. So this worked. But why are we missing the first 40 events? Because this is a bit of a race condition. When my Java application was running, it was very fast to start up and run. And it basically shut down before logstash was even available. And then the Java application could never deliver its logs. And this is kind of the main downside of this approach. This will also apply if your network is down. Because if you have a log file, your Java application can always write that log file. And if everything goes wrong, you can still go back to that log file. And by the way, FileBit will just see like, oh, the network is down, I cannot deliver the logs. But it will pick up later on and say like, oh, now Elasticsearch or Logstash is available again. I will just forward all the missing logs. Whereas if you just have them in memory, since you don't have the file, you might lose events. Either because the application shuts down before it can forward all the log events, or if Logstash, for example, here is not available for a longer time, you might just run out of buffer, because Logback, for example, uses 200 megabytes for buffering log messages by default. If that is full, it will just throw away the oldest log messages. So you might lose log messages in this approach, and this is kind of one of the main downsides here as well. So what we have here is, the nice thing is there is no file, and we don't need parsing, and multi-line statements work. So this is all good. The problem is what happens during an outage, and especially if your network is down, you're probably most interested in the log output, what has been happening. So that's exactly when you don't see anything, which is a downside. And the other thing is you have a bit of coupling, because now in our log appender, we had to configure where is Logstash living. And if we add a second Logstash instance, we would need to reconfigure our application so that we would forward it to that Logstash instance as well. So that's kind of the combination problem that you need. Yeah, you have a bit more coupling. That's why it's not so nice. That's why we go to the third approach, which is the structure approach. This is kind of like the thing that kind of makes your life easier. So what you basically do is you write to a structured file, a JSON file. Since Elasticsearch also stores JSON, basically FileBeat is just tailing the JSON file and can store it into Elasticsearch directly. Do I need Logstash anymore? Not really, because I don't need any parsing. I can just store what I get. So what do we get? We have, rather than a .log file, we have a JSON file, which looks something like this. You can see here we have a session, a loop, the timestamp, the log level, the thread, the method, everything. We have a stack trace, which is mostly empty. How do I handle multi-line statements here? Do I need to watch out for multi-line statements, or is this handled by the log appender? Yeah, so this one here, this is our stack trace because this is the longest line as well. And you can see this one here is escaped. So new line, tab, and it's just one long line. So you don't need to watch out for multi-line statements. There is nothing to be broken up here. Just to give you a quick idea how to configure this one here, basically, we have a rolling file appender, so we just create a new log file and we rotate it every day, and I think we keep 7 days around. And what you then just do is you say, like, this is basically what your log appender has, put it into this field. So put the log level into the field log.level. And this is how it will show up afterwards. And you can just tail that JSON file, put it into Elasticsearch, and be done with it. So let's head over to the structure index. How many events will we have in the structure index? Hopefully 80. Let's see. This looks good. We could, for example, again say here log.level. Then it will just suggest what are the different levels we want. Let's go for error now, just to have 2. We can open one here, and you can see this one is nice and just worked, because you have here the stack trace is just in its own field. You have the message, wake me up at night. You have that MDC information as one big field, but you also have user experience as a key value pair. So for example, we could say here, and user dot, what was my user experience? What did I call that field? User underscore experience. User experience. Equals. Luckily, it supports emojis everywhere, or we just go for this one now. We want the user experience, and you get the same too. So you can even search and do everything around emojis here. So this works. You can just get that information. Is it a great approach? Yeah, this is pretty good. The nice thing is this is kind of the right format, and it's structured, and you don't need to do much parsing. The kind of downside is sometimes people find it a bit harder to read the JSON log file than the regular log file, and maybe you have a little overhead in JSON serialization. But otherwise, this is an easy approach. Like, you don't lose log messages, you don't need to do parsing. It's kind of a good combination of all the different things. So, what happens if you throw your application into a container? And I assume this will be mostly Docker for people. So, where do you log? Generally standard out, right? So you just log to standard out. You don't care about those weird files anymore because we don't want to mount around files. What we basically get is then so we could, for example, just say like docker PSA. Somewhere there is my Java application in there. Even though it's very hard to read, this one here, Java logging, I think this is the right one. And then we can just do docker logs, that ID, and then you can just see this is what the system out log is doing, and you can see that with docker logs. How do I get that into my stack? Because probably I don't want to figure out IDs and see what is going on here. Let's take a look at, I haven't shown you many configuration files also because they're often not that exciting. But what we're doing here basically now is we say we have a provider and the type is Docker. And basically this is all you need to set because my container will know the default Docker log is in this location on the file system and how to pick that up. So that will take that one here and just collect that. Also, it's kind of nice that we can add the metadata. Add Docker metadata basically based on the Docker ID. You can then figure out these were all the labels that were on that Docker container, and this is the version of the container, and this is the base image, and all of that metadata can be added to your logs, and you can filter on that as well. How do we get that metadata? So in the path to the log file, there is the Docker ID, and I kind of need to figure out the Docker ID, what is the Docker metadata? How do I get that information? I need to mount the Docker socket into the sidecar. So this is, I run this in a sidecar, and I put the Docker socket into that so that it can pick that one up. So basically what you do is you run your application in one container, you have FileBeat in another container as a sidecar, and then you just give that sidecar access to what you want to collect, and then you get the logs from that one. Just to give you an idea what that will look like, or where do you put it? A general pattern is called sidecar, so you don't put FileBeat into your Java application, but you just run it as a separate container, and that will pick up all the logs for that host. And it's just all the Docker logs end up on the disk. The FileBeat will pick them up and forward them. How does the sidecar get to the Docker log files and the Docker socket? You need to mount them correctly. So those who like YAML, this is your part now. So somewhere down here we have FileBeat Docker for Elasticsearch. This is the one we want. So what you need to do is basically, this is the default location where all my containers are logging. And I basically need to mount this into the sidecar, read-only. And this is where we are picking this up. And now with that setting, here, this is where we can just say like, okay, you know where the default Docker location is for logs, and we're mounting that in there correctly, so we can just pick up, this will pick up these log files correctly. The other thing that we need to do for the metadata, for example, we need to mount that socket, so we can actually have the socket in the sidecar to query the metadata. Okay, so let's see how many log events do we have. I need to add my index pattern for Docker. Let's quickly add that one. So we have Docker. We have a timestamp here as well. This is good. How many log events will we have now? I'm afraid it won't be 82. Let's remove this one and switch the index. It will be many. So it will be, okay, 2,828. Why is it that many? Yes, I didn't specify which container to log from. And since all my other components, everything is running in Docker, it just picks up the logs for everything, not just my one Java application. So you have a lot of logs. But the good thing is, since we're adding the metadata, you can then just filter down on that. I'm not even sure. No, this is not the one I want to. Container dot image name sounds reasonable. And then it will give me all the images that I have running here. So you can see this is, for example, the image name of my Java application. So this is Java logging version 1. I can filter down on that one and just see that one here. And then we have 82. Why do we have 82? Yeah, this is just a logging artifact. So I go to the very beginning. What you get here is basically you get the output of this one was when I started my application the very first time, and it couldn't connect when I was sending to Logstash directly. It couldn't reach Logstash. And that's what when the logging appender basically was logging that message. But this is not the Java application itself. This is just like, it couldn't connect to Logstash when I told it to log to Logstash directly. This was the second pattern basically that I was showing you. This is just about this one. That's why we have 81 here. But otherwise, you can see this all works. So we could, for example, go to our error again. If I look at the error, this here, this is all the Docker metadata. And you could search on any of that. So for example, this one here, the labels.app is, I called my application FizzBuzz. This is just the label I have applied to my Docker image. And you could filter down on that one, for example. And you can see this is a production image, and my container name is Java application, and this one here is FizzBuzz, and at the very end, here you can see this is basically the actual log output that we want. So here we have the package again, the loop, the message, the stack trace, the user experience, all of those different fields are here now. So we have picked up all of those, so this is working as expected. There are just a few more twists to that. Because Docker adds fun. So first off, if you want to figure out how to configure that correctly, this is part of the beats repository. So for FileBeat and all the other beats that we have in deploy Docker, it will show you some deployment configurations and how to set it up correctly. It's a bit hidden in the repository, and I'm using the same patterns in my application, but this is how to set it up. By the way, there's another folder next to it for Kubernetes, which will be the next pattern I'll quickly show you, to set that one up as well. Basically, all you need to do is you need to say, like, I want to collect the Docker logs, I want to add metadata, and this will just collect all the information for you, and you're pretty much done. Without the Docker metadata, you don't get metadata, and it's not so easy to filter down on the right container then. This is what we've seen. Sometimes you were missing the last line, but I think Docker changed it, because unlike all other or most other log appenders, Docker logs were not ending a new line at the end. And then FileBeat was never sure, like, did this line finish, or is there more to come on this line? And then it wouldn't collect the line, so it would always wait for a new line. And the Docker logs, at least for a long time, didn't add a new line and have an empty next line, but we're just waiting for the new line for the next log event. So sometimes you were missing the very last log line, which is not the case here today. One other thing that is very nice, if you have multi-line statements in there, and you don't want to kind of like say, like, if it is this Docker image, then apply this specific rule. We have another nice approach here where we can basically say, like, these are labels you apply to the Docker image you're monitoring. And then we are using this specific namespace here, CO elastic logs. You can add the multi-line patterns that we have seen before. You can basically bake that into the Docker image as a label, and then the FileBeat will pick that up automatically. So rather than saying, for this log file, apply this rule, you bake the rule into the Docker image, and the FileBeat will then pick it up automatically and apply it. So it's kind of easier, that mapping is easier. One other trick that I've not really mentioned here is FileBeat basically knows, for this file, I've sent all the logs until this specific point, and that information is kept in the so-called registry file. And I want to keep this registry file outside of the container. Why do I want to keep this out of the container? Either in case of failure or just because you upgrade. Because if you upgrade the FileBeat that is collecting the log files, if you just replace the container and you miss that registry file, it would probably, or it would suddenly find all the old log files and say, like, I've never seen those, let's send them again because I haven't. And then you would have duplicate log messages all over the place. Whereas if you keep that registry file outside of the container, then it would know, okay, this is all I've sent already, so I don't have to send these old log files again. And that's why you want to keep that registry file separate. You could put that into different index names. So for example, you could say when the Docker metadata container name is Java app. I want to put that into an index called Docker Java rather than just Docker to split it up by application, for example. You could do that. We'll skip that. That's not so important. One other nice thing that I haven't shown you yet is this one here. And I'll give me a second to set that one up correctly. This is for those of you who like tailf and want to get back to tailf. So let me add the right index that I'm interested in here. That is Docker is the index that I want, and I don't need this specific field. Let me just apply this one. This is basically just streaming log events. And I could just turn on streaming. I can run my application again. And you will see here, this is the last event we had, 11:03. And we can just keep this running, and this will just keep tailing our log files. But you can here say, you can filter down on that one as well, container.labels application equals, and then I could just say just my FizzBuzz application, and then you see we're just filtering down on the log messages for this specific one, which also works as expected. And you can also search in that, highlight, jump to the next error or the previous one, and you would even have like little red dots every time where there is an error. And you can still just stream your logs and tail in those. Okay, we can skip those. That's also not so important. This one is a good one. Some applications are funny when they start up, like Redis. They have this ASCII art when they start up. Will this be very helpful if you want to centralize your logs? Not really, right? So what you can do for that one is you can use a template, and basically we're using the Docker metadata where I say Docker container image is Redis, and then on this one apply this exclude line rule here, and this is basically filtering out the metadata or the ASCII art. So you're getting rid of that one. Okay. So yeah, Docker is kind of the hot stuff, but it's adding some more complexity that you need to keep track of. And very quickly, because we're running short on time, who's using Kubernetes? Yeah, logging on Kubernetes is also interesting. Where do you put your logger? Or where do you put FileBit on Kubernetes? Yeah, either the system or generally in the daemon set. Like daemon set is basically, it runs one instance on every single host. And that can then just tail all the logs for all the Kubernetes pods that you're running there. We have the deployment examples again as well. Like this is a different folder than Docker, but just for Kubernetes here. What you basically do is you have a configuration here, and you just say, rather than saying, I'm collecting Docker logs, you tell it collect Kubernetes logs, and it will just pick them up correctly. And this is the path where it expects them. And here you can see you have the Kubernetes container ID, and based on this one here, we can look up the metadata as well. And the FileBit can either sit inside the cluster, and then it can just fetch the metadata from the Kubernetes API server, or if you install it on the host directly, you will need to tell it where is the Kubernetes API server, and you can get the metadata from here. So this is how we basically pick up the Kubernetes metadata for each container that we're running. And then it will look something like this. So it's very similar to the Docker example, but you have some Kubernetes-specific things. For example, here you're running this on Minikube in the default namespace, and this is the pod name. So you just get the metadata for Kubernetes as well, and you can filter down on that too. You can skip those are not so important. If you have the ASCII art problem again, this is how to exclude the lines from the ASCII art from Redis when you start it up. You could customize the image, but it's also a bit too much. Yeah, it's even hotter, but it's even more complex if you want that. People often ask us, like, can I use all of this, or should I log on Kubernetes? And we're always like, yeah, you can, but the real question is always, should you? Because only do what is really needed for your use case. So to quickly wrap up, if you want to run this, you can just, what I've shown you today, you just clone the repository, run Docker Compose up, and it will just do everything for you. You can just try out all the examples. It also has all the configuration files, which, well, we've skipped over some configuration files, but we have everything in that repository. I just do Docker Compose down at the end again, and everything is gone and cleaned up. So these were the patterns. Parse, if you have to, because it's the classic thing that you normally have. Send if you really want to, because you might lose messages. If you can, write structured information, because then you don't need to do parsing, but you also won't lose messages that easily. If you have containers, FileBeat ties well into containers, and you can just pick up the default Docker logs, and the same applies for Kubernetes logs to fetch those. With that, we'll have questions, and I still have the questions from yesterday here. This is not, oh no, now it refreshed. What is the purpose of using Logstash if we use FileBeat? Yes, so generally, you don't always need Logstash anymore if you have FileBeat. For example, if you log in a structured format, you don't need Logstash anymore. But for example, if you want to do the parsing, you can also do that in Elasticsearch nowadays, but for parsing and heavier lifting, Logstash is still required. It's not for all the use cases. I think in 80% of the use cases or so, you're good without Logstash nowadays, but it generally works well as well. Or for the larger use cases, we often see Logstash. Directly using Logstash Appender is limited to TCP or also possible to use UDP. No, you can also use UDP, which has less overhead, but it also has the downside that you might just lose log messages because UDP. That's a trade-off. Normally, you always use the log messages that you're most interested in, but that's just something that's Murphy's Law, I guess. And there's no easy way around that. And I think we're running out of time. Any final questions? Otherwise, before you run away, I have stickers. And I have, since I just came from a conference, I have a lot of stickers. I'll just throw them here. Come to me, get stickers if you want to. Or if you have more questions, just find me and ask as well. I hope everybody learned something. Enjoy lunch.